Good afternoon to all. Once again, I welcome back you all for this afternoon session. Now I request Maya Bharati to to take over the session.
Hello everyone. Good afternoon. You guys can hear me clear, right? Okay. So today morning session we talked about RNN, their use cases, the types of RNN, and the most important RNN model, the LSTM, as well as GRU. We didn't go in depth in GRU because GRU almost resembles an LSTM architecture except the part where it got rid of 2, 3 gates and it got rid of the memory state function, cell state function. So that's the overall gist of it. And I hope it's been a useful and resourceful session to all of you. Now, let's get into the coding part. The afternoon session is supposed to be a hands-on session. So, sorry. So the afternoon session is supposed to be a hands-on session where I'll try to provide you with all the terminologies, all the coding terminologies, how to implement an RNN, how to implement an LSTM, how to implement an GRU, and what kind of data that we can use, what kind of data that an model expects from an input perspective, and those things. I'll try to walk you through those. Also, I mostly the data science AI community uses Python as their primary programming language. So we will be using the same as well. In order to access the code that I created for this session, I have made a GitHub. I'll send you the GitHub link. So I will send this GitHub link in the chat box. You can go to the GitHub link and click on this code button, and then you can just click on this download zip button. So where you will be able to download the code in the zip file format. It contains the data as well as the IPython file. And IPython is nothing but a Jupyter notebook environment. That file format is nothing but whatever it's in this file in the same HTML format, it will be represented in the IPython file, IPNBY, IPython notebook. So that is the full form. So it will be in those file format. In case you don't have your own Python environment, or in case you don't have access to any kind of pip or any kind of Python environment, you can go for Colab, Google Colab. It's an open source free initiative that is developed by Google. All you have to do is go to this, just type Google Colab notebook, and you will get a notebook. You will get a notebook out of it. So how you can view this is, this cell is there, right? Let's consider this as a cell. For this cell, this cell is same as what we have here. Okay, this cell is same as what we have here, and Colab will mostly have all the packages. Python, I'm just taking a leap here and assuming you know about Python's packaging modules, those kind of information related to Python, because yeah, I am assuming that because it's too literal. But anyway, in case if you are not familiar with it, I'm just giving a gist of or a brief of what it is. So every functionality in Python will be made as a Python module. What you call a module is some kind of file which you can import using an object versus file name reference. So this is the file name, and you are importing that file name as PD. This is an alias. So you can use something like this. In case if you don't find, for example, NSCPy is a package which will not be available in Google Colab. Let me give you an example. So this is a so for example, in case you want to try this in Colab, you just paste it there and then run it. You can either click on this or you can press Shift Enter. So it will run the cell. Initially, the Colab will be a little bit slower because it's running in your browser. So if you see import pandas as PD has run successfully, but if I import this NSCPy, it will throw me an error because module not found. This is not a default library where most people use it. Okay. In order to get that into your system or get that into your Colab, all you have to do is, so whenever you're facing some issue where the packages that I have used in this GitHub is not running in Colab, if it says this error module not found, no module named NSCPy, something like that, just copy this and then say pip install NSCPy. So if you see here, I'm just zooming in. You're able to see, right? It needs an exclamation mark, okay, and then pip, and then install, and then NSCPy. Once you do that, the file will be downloaded. That is the package, the appropriate package will be downloaded. After that, you can successfully run this import. So this is the only problem that you will be facing if you are using the files that I sent to you through GitHub in a Colab. If you have your own Python environment, then I can assume that you are familiarized with Python modules and stuff. So in case if some packages are not in your own environment, you will be you will have the knowledge to you will have the necessary knowledge to import that package using the same pip command in terminal or the bash shell based on whatever OS version you are in. If it is in Windows, you can use bash or PowerShell. If it is in Linux, Ubuntu, CentOS, Fedora, those kind of Unix system, you can use pip. Or you can use terminal, or if it is a Mac like the one that I'm using, you can use pip, no issues. So or the terminal command to install pip, right? That is the only thing that you are gonna face. Other than that, I've tried everything to be as friendly as possible so that anyone can run it in any environment. If only problem is if you're going for Colab, this one package, only this one package NSCPy, this one package will not be available in Colab. Other than that, every file will, all the packages in every file that I'm sending you, I mean all the packages that every file in this GitHub, in this particular GitHub, will be available in Google Colab itself. You don't have to do anything, just copy paste each and every cell into a single cell in the Colab notebook and then run that. You will be able to successfully run it. This is just in case if you don't have the Python environment in your local machine or any machine for that matter. Okay, so yeah, let's get into this hands-on session. Pandas is an library which is widely used for table-like structure. Okay, this is an Python library which is widely used in this data science as well as AI community to import as well as export table-like structure. Also, you can do many sorts of manipulation on this table. So whenever you have an Excel file, whenever you have a CSV file, or if you have or if you have a JSON file, or if you have a JSON file, all these files can be imported as an imported using pandas as a data frame. So when all the files, or you can even connect it through an SQL database itself. There is an option to connect it to an SQL database itself. Right now, the scope of this session is limited to understanding LSTM as well as understanding how RNN works in a particular type of concept as one, and also the other thing that we are trying to go through is what is the time complexity, what is the space complexity, or how LSTM is different from GRU. For that, we are trying to, for that, we will be seeing one demo. And then there is this time series model, which where we'll try to predict the stock price of Maruti, uh, right? And then we'll try to work with retail industry data where it's strictly numerical, and we'll try to impose RNN architecture on a numerical data once, a time series data once, and then we'll try to find the difference between as we discussed in the morning for the theoretical part, saying that LSTM is taking more time, GRU will take less time, those kind of things, right? We'll try to see how it is in the real time, and that's the overall agenda of this hands-on session. So three things essentially. One is the time series data prediction. The second one is the uh, Canadian retail price prediction, which is an retail market data set. And then we have an uh, yeah, and finally we have an demo data set which we'll download from sklearn, and we'll use the same data set to train an LSTM model and then a GRU model, and we'll see what time it takes. Okay, these are the three things that they're going to do. So as I was saying, pandas is an data frame library which can read many data sources, as in the CSV or pandas, or it can even read Spark distributed based file system also. And NumPy is a Python package that is primarily used for uh, mathematical computation. So its full form itself is something like numerical Python. So it is used for mathematical computations. And then there is matplotlib. Matplotlib is the one where is the one that is widely used for plotting, visualizations, those kind of stuff. But it's pretty basic, and it's uh, yeah, pretty novice. If you are an advanced Python user, or if you are an more familiarized Python user, you can go for other tools like Plotly or Seaborn or Bokeh.js. Those kind of tools are pretty hardcore, and it's pretty customizable when it comes to visualization. But Matplotlib is pretty basic, where you don't have to worry about anything. You just paste your data, and it will provide you with an visualization. Date time, yeah, NSE Pi. So initially, what we are trying to do is, one second. So what we are trying to do is, we'll try to see. So yes. So what we are trying to do is, we'll try to get the data, that is get all the available data from this particular website, which is NSE, this is the direct website for National Stock Exchange. It's been there for 25 years. So these guys are pretty hardcore when it comes to Indian stock market. And we also have BSE, which is Bombay Stock Exchange. So why India has two markets is simply this. BSE started first, and since they started it in Bombay, they called it as Bombay Stock Exchange. And those time, Mumbai used to be the hotspot of India because it had a pretty good port connectivity and everything. So first they started BSE there, and then they started National Stock Exchange, is like a regularized one, which is almost equal to a government organization or something like that. This is the the two stock exchanges, Bombay Stock Exchange as well as the National Stock Exchange, are part of Indian stock market. What we are going to do is, we'll try to get information about one particular stock. or one particular symbol or index. Okay, so Nifty consists of 50, 50 organizations in it. That is why they call it Nifty 50. And Sensex consists of 30. So Sensex is nothing but top 30 organizations. Nifty consists of top 50 organizations that will decide, or that will have their own impact on the market's movement. Okay, whenever you see someone something in news like NSE increased 2%. So if you see here, NSE is increasing by 0.06%. What do they mean by NSE is increasing? That means collectively these 50 industries have been increasing collectively, not individually. These 50 industries have been increasing collectively. That is why NSE is increasing. Let's say there is a hitch in the system, and one of this UPL, let's say UPL is going down like anything. It goes down from currently it's at what, open, high, low. Yeah, if we say NTP, if we say UPL is going to go low, then it's at 446. Let's say it goes to 200, or 100, even 100. If it goes to 100 rupees per share, then the Nifty will actually start decreasing, because it doesn't matter which company or how many companies is performing bad. Nifty as a whole will be affected by the performance of each and every organizations in the Nifty 50, because they handpicked these 50 organizations and said that they collectively represent our market. So one of them is going down, then Nifty will go down. If there is a rise in anyone, then Nifty will not get affected, because they collectively represent Nifty, but the organization as an individual is not representing Nifty. So if you see, when it says 0.10%, it's increasing. Look at the green things, like look at the green highlighted things. These many companies. These many companies are increasing, so Nifty is increasing. Okay, these many companies are increasing. That is why Nifty is increasing. If any one, at least just one company has been increasing constantly, or just one company saw a sudden hike, let's say Bajaj Finance says that it has collaborated with Swiss Bank or something, then Bajaj Finance stock price will go high like anything. It will, from 5,000, it will reach like 10,000 or 12,000 per share. It is possible to have 10,000 or 12,000 per share. If you see here, this is Stiram Cement. Okay, this is Stiram Cement. SRECEM is Stiram Cement, and it's trading at 25,000 per share. So if you want to own 1%, not even 1%, 0.01% of Stiram Cement, you need to have 25,000 rupees invested, and these guys will be like, you should buy at least 10% of our stock. So you should at least buy 10 shares. If you buy 10 shares, then you need 25,000 into 10. What? It will be 2,50,000 rupees. Okay, so when a company or a particular organization stock increases, then that particular organization's boom or hike will have no effect on Nifty. But when a particular organization is going down like anything, then it will definitely have an effect on Nifty. Okay, so yeah, that's how it is. So to identify each and every organization in NSE as well as BSE has their own symbol. A symbol is nothing but a set of strings that will uniquely represent the company. So if there is Bajaj Finance, it is Bajaj's financial sector. Okay, if it is Bajaj FinServe, it's Bajaj financial sector which holds the technical department. Okay, if you see here, there will be the best example would be HDFC versus HDFC Bank. We all know HDFC is a bank. What we don't know is HDFC has multiple subsidiaries on its own, which is HDFC is an equity broker using which you can buy or sell stock. HDFC has their insurance plan, which is HDFC Insurance. HDFC has their own banking sector, which is HDFC Bank. So HDFC as an organization is different from HDFC Bank. Okay, this is same for Tata. So if it is Tata Motors, then that represents Tata organization's motor sector. If it is Tata Steel, then that represents Tata organization's steel sector. If it is Titan, then that represents Tata's organization wearable sector. Okay. So again, see here, this is HDFC Life, right? What is HDFC Life? It's a life insurance sector of HDFC Bank, right? Also, Reliance is having something like Reliance will have Reliance and Reliance Petroleum will be there. Reliance Communications will be there. So these kind of things are there. These kinds of things are there. Again, see, if you see here, Bajaj Financial Services is different and Bajaj Automotive Industry is different. So each and every sector, each and every organization will have its own symbol. That symbol will be a set of strings with some special characters if needed. So the special characters, what I'm referring to is like hyphen or comma or something like that. So with some special characters, and each and every symbol will be unique to that organization. Bajaj FinServ, FINSP will not be assigned to any other sector of Bajaj or any other organization for that matter. Okay. So it has values like, okay, so we are trying to get value from this site and get it in a format that we can actually manipulate or slice and dice it or work around with it, anything that we want to do, any kind of operations that we want to do. Okay, that is why we use NSE Pi. I also took the time to get a little bit of give a little bit of introduction on the NSE's market, as well as what is the NSE stock market, and what are all the values, what is the impact, something like that. And so yeah, date time is an Python package which is used to perform operations on date indexes. So if you see here, this is the date value, right? If I need to perform any operations on it, I'll use the date and time delta or date time packages in a whole. Okay, so warnings is nothing but this is a package that I use mostly. So whenever I run something pretty hardcore, it will just stump me with many warnings. It will say your system is not capable of this. Your system is not capable of your system version is not capable of this. Your pip version, Python version. It will actually find as many reasons as possible to show chunks of data from the code. So what I'll do is what I'll do mostly is I'll filter these warnings. So that my output will be mostly clean and prioritized. So now what I'm doing is also if you people wanna try the hands-on, like do it side by side, feel free to do it. In case if you're doing it, let me know so that I'll stop a bit and I'll see what is happening, where it is going and stuff, and we'll carry on with that. Okay. Okay, it's throwing some error. Right. Says operation timed out. Okay, I'll see what it is. Just give me a sec. I just ran it today morning. It ran perfectly. So now let us get into this get history. Okay, it ran successfully. So this get history. Get history is a function that is available in NSE Pi. If you are interested in knowing what are all the functions that are available in NSE Pi, so what you can do is NSE Pi. What you can do is you can import plainly NSE Pi. So what I am doing here is there is a file called NSE Pi, and that from that file I'm just importing one single function, which is get history. If you want to know all the available available functionalities of that file or of that package, you should use it like this. So in Jupyter Notebook, or in, even if you are trying in Colab, you can try this. If you say import the package, and if you click a dot on it, dot next to it, and then press tab, it will provide all the functions that are associated with the package. These are all the functions that are associated, that are available in that package, and we are using this one, the get history one. So what happens when I say dot is, I am just accessing that file as an object, and then when I press that dot, it says that implement whatever class that is available in that in this NSE file, and then provide all the functions inside that class as an object for me. So these are all function objects, you can say, and this you can use it as a normal function along with the class object. Now NSE will be my class object, and then I'll use this function, whatever function that NSE provides, or whatever function that I need from NSE. So if I run it now, the get history command is running. In that command, what we have specified is the symbol, which stock that we need from. So when I say Maruti as a stock is here. Okay, it is here. If you see clearly, are you guys able to see my screen clearly? So Maruti as a stock is here. What I'm trying to do is, I'm trying to get data for this particular stock from the start date, which is 2017 1 first day, 1st of January 2017. I'm trying to get the stock price from for Maruti from NSE with the start date of 1st of January 2017 and the end date being today. Okay, so I ran it, and the data shape is 979. The data shape is nothing but so just a quick question. You guys are familiar with Python, right? Is there a session on Python which is conducted before about data exploration, EDA, something like that, pandas? Uh, so why I'm asking is, do I need to go through all these shape or tail attributes, or you people know what it is, and it's all right to uh, skip the explanations for this process? Anyone? Okay. So shape is nothing but what is the number of rows and what is the number of columns. It will first display rows and it will next display columns. So we have 79 rows and 14 columns. So 14 columns. And the tail attribute is nothing but we are viewing the last 5 data points in that particular file. Okay, we are viewing last 5 data points. So if you see that 20, 12, 14. Okay, but if you take a look at it, I said today, right? Today is 15, correct? Why I'm not getting 15th day, that is 20, 12, 15th data is the market has not closed yet. The market starts at 9:30 and closes at 3:15. Okay, once the market closes, after that alone you can get the close price. That's the logic, right? Once the market closes, after that alone you will get the close price. So you are trying to access the close price data without the market being closed. So NSE is taking care of this. Get history from NSE is taking care of that error for you or that mistake for you, and then it says that I'm only able to give you till 14. So it gives you till 14, and then data.head. Head is the top 5 attributes. So we want the data till today, but we got it till yesterday, and we want the data to start from 2017 1 1. Why it is not starting from 1? Because January 1 is the leave on stock market. Stock market will be available only on weekdays, which is Monday to Friday. If there is some kind of national holiday on it, it won't be available. The stock market won't be available. That means the market will be closed on that day, and the work timing is 9:30 to 3:15. That's the work timing of Indian stock markets, both NSE as well as BSE. This is the timing. Uh, so we are seeing the head is nothing but the top five, which we have like 2017 1 first of 2nd of January 2017 from that. So it has more number of columns. If you need, you can cut down those columns, or if you need, you can use these columns to find different things. Right now, what I'm going to do is I'm trying to predict the price, close price of Maruti stock with RN. Okay, but today morning I mentioned that I presented a paper, right? That paper, what I tried to do was I tried to predict the movement of this volume that is going to be traded for any stock from Sensex, not from Nifty. I used Sensex, from Sensex at any given time. So you can choose any attribute, any of this attribute. So one important attribute will be open price. So you let's say you train a model that is accurately, you want to train a model that will accurately able to predict the open price of a given market, any market for that matter, not only BSE or NSE. You can go for Dow, SP and Jones. You can go for American Bulls market. You can go for any kind of market for that matter. But the point is, you need to choose an attribute that is varying across time for it to be a time series problem. Okay, now what we'll see is we'll try to have a general look at how data is distributed. Just a second. My throat is like throbbing. I'll have a sip of water. Okay, sorry for that. So, yeah, this is the data. This is how the close price of Maruti stock has been distributed. If you take a look at it, it went down between 1st January to January of 2020, as between January of 2020 as well as July of 2020. Why is that? Because of the COVID effect, and because of this COVID effect, and yeah, sorry, because of the COVID effect. Generally every stock in the market went down due to COVID situation. But if you come here, what happened here, if you take a look at it, it went down like it had a huge downfall, which is similar to what happened in this COVID situation. What might have caused it? If you take a look at the history of events that happened between 2018, 7th of 2018, that is July 2018 till the 1st of that is January of 2019, you will be able to see that the CEO of Maruti company, Maruti as an organization or as a family, stepped down, saying that he doesn't find any future in the company's ideas. He literally said that. Because of that, the stock went down like anything. If you see here, it was traded 9,000 and more than like close to 10,000, let's say 9,800 or something, close to 8,000, 9,800 or something on one day. And then after a few days later, it went down till 6,000, which is 3,000 less, because of that guy being a total unprofessional person and saying that I'm ready to step down because of I don't see any future in this company. If he has some opinion, he should be like having his own intuition and something, but I mean not intuition, should keep it to himself, but yeah, he didn't do it. So because of that, the company suffered a huge downfall. So what we are doing here is np.array. As I said, np is an numerical Python package. We have this functionality called array, and what I'm trying to do is I'm trying to pass this close, that is this column, from the data to store it as an array, just to store it as an array, because this is just an initial step that I'm doing to separate the value or the attribute that I need from the whole sum of data. Okay. And then, yeah, this is what I'm trying to do. And then what I'm trying to do is calculate variance. Again, np.where is an function that will calculate variance. What I'm trying here is I'm going to say that I'm taking a round turn of 6 data steps. If it is one data point, I'll move it to 6. I'll For the first data point, I'll take the sixth position value. For the next data point, I'll take the 7th. So I'm just rotating the circle a little bit. Okay, someone has messaged that share the notebook at the end of the session. I've shared a GitHub link which contains all the notebooks, all the files, all the data files also, which I'm using in this session. I think Miss Hemalata MCA. In case if you don't find the GitHub link in the chat box, I'll share it to you again. Uh, you can find all the codes and data available in this GitHub. So here we are trying to calculate variance. What is variance is we are trying to find what is the difference between two data points, or as I would like to call it, in this time series data, there is a point A and there is a point B. Okay, you want to reach from A to B. For this, you need to know the distance, right? That is going to be D. Like that, in time series data, from one time step to another time step, how much the values are varying between each other. And the basic assumption between the values that are varying between each other is that is the rate of change at which the value is changing given the time. Okay. So that is the variance, and we'll try to visualize the variance also. So initially at 2017 there is no variance, correct? And then in the overall time period, we have only two huge variance because it went down a steep slope and at this instance, and then it went down and on another steep slope at this instance. So we are trying to find the variance of these two, and here are these two variance points. Okay. So now what we are trying to calculate is moving average and standard deviation. What is moving average? Moving average is nothing but we are instead of uh, okay. The first question is what is average, which is nothing but number of elements added together divided by the total number of elements. Correct. The problem there is if there is one particular element or one particular value, let's say you're adding 1 plus, once again, let's say you're adding 1 plus, 2 plus, 3 plus, 4. So the average for this four elements would be divided let's say you want to find the average of 1, 2, 3, 4. So the average for this particular sequence would be 1 plus 2 plus 3 plus 4 divided by 4. That's the average, correct? But when it comes to data science or machine learning, there is a problem that if you generally find an average, if the fourth or if any variable is huge, let's say the fourth variable is 410 instead of 1 plus 2 plus 3 plus 4, and you are finding an average which is going to be 1 plus 2 plus 3 plus 410 divided by 4. If you do this, the problem with this approach is the 410 is going to have a huge impact on what is going to result as an average. In order to reduce that, we'll go with an approach called moving average. So what moving average is, it will, let's say the for moving average, taking two strides. Okay, first what I will do is, I'll add these two value and get an average for it. Then I'll add these two value and I'll get an average for it. Then I will add these two values and I will get an average for it. And then I'll add this value with this value. Okay, and then I'll get an average for it. So essentially I'll have four averaged values. That is most likely a normalized one, because if I add 3 plus 410, it's going to be what? 413, correct? And then I will divide it by 2. Yes. So 410, 413 will be reduced to uh, what? 212 or 212, 211 or around that zone, correct? Or it would be reduced to 206.5 to be exact. Okay, then I'll add 410 plus 1, which will be reduced to 205.1. So this 410 will be reduced and then I'll divide it by 4. This is the concept of moving average. I'll have four values, which is a summed average of each and every individual element across each other, and then I'll add those summed average and then calculate the average, which is called moving average. Okay, done. So the next step is finding the moving average as well as standard deviation. Standard deviation is nothing but what is the rate of change that is occurring across all the data points. Okay, so we'll calculate the standard deviation as well as we'll calculate the standard deviation as well as moving average. Now I'm considering here 12 as my moving averages stride. That is, I'm adding 12 elements together to form one summed average element. Okay, so I have 979 data points and I'm adding 12 elements together. So this is my moving average versus close price versus standard deviation. This is my standard deviation. The red color one is my moving average. The blue color one is my moving average, and the orange one is my close price. That is the original price. From where I'm trying to calculate a moving average, from where I'm trying to calculate a standard deviation. If you take a closer look, if you take a closer look, just by calculating the moving average alone, I am able to beat the market by one time step. See, the moving average is giving a spike before the spike is actually happening in the market. This is going to be my actual close price, but the moving average here is already started increasing, and it shows the spike there, which is a blunt spike. Okay. We'll see how this moving average, adding this moving average into the RNN will give us a proper way to establish things. Yes. So the next one is we'll try to plot the difference between two elements. What this will do is data of close will get the close column, and then if you call the diff function, it is the function that is available in pandas as a functional object. So what this will be doing is it will try to find the difference between two adjacent data points. Okay, and these two adjacent data points will represent a single source from which the data has been evolved from. Okay, so this is nothing but what is the first value, the second value minus the first value. It is based on an assumption that the second value is going to be higher than the first value. If it is not, we'll go with the negative. If it is yes, we'll get a positive value. If it is not, we'll get a negative value. So that is why we have 0 minus signs and 0 plus signs. Okay. So here what I'm doing is I'm just trying to see what are all the trues, what are all the false values that is available. If there is any non values inside the diff, will there be any non values inside the diff? Yes, there will be, because let's say you have 979 data points, correct? You have 979 data points, and what you're trying to say is I'll form a new set of data by subtracting each and every data point with the successor, with its successor data point. So if you have a column of 10 rows, what you are essentially saying is I'll get a new row by subtracting row 2 minus row 1. The second row of the new column would be like row 3 minus row 2. Like this, if we keep on going, the 10 values in this first column will be converted into 9 values, because we are not doing it in a round robin fashion. We are only doing it in a linear fashion. So for 10 values, we'll get only 9 values in the next column by applying the same subtracting approach. That is why there is only one value which is empty in the diff. Okay. So here what I'm trying to do is I'm trying to fill NA function is used to fill the NaN types, that is the empty values in any data frame. In any data frame with the value that you want. I'm saying that fill that NA position, that is wherever there is a NaN value in my data frame, fill that with a 0. It will fill that with 0. And then this in place equal to true is nothing but pandas as a concept, it uses this ideology, which is it will try to not alter the original data frame. that is the original data. It will always try to produce a new set of data which you can use, whatever manipulation you do. So in order to overcome that, they also introduced this feature called in place equal to true. So whenever you say in place equal to true, it will not it will alter the original data instead of producing a new set of data points. Okay. So the next thing is, we'll try to convert the diff as a data point, data frame into a numpy array, which we already did for the close price. Now we are doing it for the diff. Now what I'm trying to do is, I'm trying to, instead of calculating it for the close price, I'm trying to calculate the diff for, I'm trying to calculate the moving average as well as standard deviation for the differentiated column, that is the diff column. I'm trying to calculate rolling average as well as the standard deviation. Let's see how it is. So if you look at it, the diff close is the blue line and the rolling average is the orange line, and then the rolling standard deviation is the green line. It actually quite resembling what is happening in the data point. Yes. And then I'm reshaping that array just to have a quick look on how it does. And then that array, I am forming a new variable called close, which is what I'm going to use to train my data. Any machine learning problem, the data that you choose is split into two formats. One is the train data, the other one is the test data. So in train data, there should be at least 70% of data points, and the test data should contain 60%. This is not necessarily the same ratio, but you can keep it like this. Also, you can choose something like 60% train data, 20% validation set, 20% test set, based on your preference. So I'm making the split. So we have 979 data, right? 979 data points, correct? We have 979 data points. So I'm just dividing it by 2. What's going to come? 489. Yes. So I'm just reducing that from 979, and then so I'm saying 686 is my total train set, and from 689, 686, whatever left is going to be my test set. Okay. And I'm importing a new function called min-max scaler. What is this min-max scaler? If you take a look at it, look at here, there is a huge variation. The data is not even being in the same zone. There is a huge variation across the data points, across all the data points. So what I'm trying to do is, I'm trying to get all these data into a single zone. Okay, that zone is, I'm trying to fit all these data between a value range of 0, 1. That is what I'm doing here. Okay, and then I'm splitting that data into a y train and y test data. So for I in range of, this is a normal for loop, and then I'm using x train as a list and then y train as a list, and then I'm appending values into that list, and then I'm converting that list into an array. Again, converting that list into an array. Now I'm reshaping this because LSTM as a model always expects 3-dimensional input. This is my row, this is my number of dimension, this is my total number of output that I'm expecting. Okay. So now what we are doing is, we are calling a model, which is going to be a sequential model as we all know it. And then we are trying to add an LSTM cell to it. And then here we have 100 units. So what happens is, in this particular layer, we will have 100 units of LSTM cell, 100 LSTM cells in it. This is our input layer. And then I'm adding a dropout to this, because dropout is necessary in cases where you are not sure about your input. Here, our input is so stationary, we don't know what it holds, and we don't want the model to learn everything from this input. So I'm setting a dropout of 0.2. What this means is, if the input has only 20% of information that the output needs, then that input will be dropped. About 20% will be carried forward. Okay. Now I'm adding 100, another 100 units of LSTM cell, and then I'm saying dropout as 20%. Another layer of 100 LSTM cells and drop out 20%, and the final layer of LSTM cells and the drop out 20%. Increasing the LSTM units will actually increase your model's accuracy, because the information that is processed and carried forward will be huge in this case. And then finally, I'm adding a dense layer, which will actually give me an output that I want in that order. And then I'm using the Adam optimizer as well as mean average error as my loss function. And finally, I'm training my model. So here, what happens is model.fit of x train and y train, which I formed earlier as an numpy array, which I formed earlier as a numpy array. And what I'm trying to do is number of epochs, number of iterations that the model should run. I'm using 2 epochs. Let's see how it does. And verbose equal to 1 is nothing but what kind of information you want the model to return on the screen, that your what kind of information that it should print here. That is what verbose equal to 2 means. So let's test our model. Let us I'll show you what is happening. So if you see here, this is the real price and this is the predicted price. The predicted price is more than two time steps behind the real price. That is, we want this line to be above the blue line, or we want the line to be most exactly on the blue line. Okay, since I had 2 epochs, what I'll do is I'll train it for 100 epochs. So while that is training, we'll take a look at what are all the steps that I ran. Okay, so now what I'm doing is I'm trying to generate a test set for our input. So initially what I'm doing is I'm getting all the close price that I trained my model on. So I'm taking all the close price that I trained my model on and calling them as input, and then I'm reshaping that into a shape that uh, the transformer, the min-max scaler will accept. The scale dot transform is nothing but what I called here. So if you see here, I called it scale dot fit to transform, correct? So for that data, I did a transform, fit transform, and then here I'm just doing a transform. Okay, and then now the input shape is 979. So now what I'm trying to do is I'm trying to have the input in the same format, have the new input in the same format that the model has been trained on. So if you look at here, I looped it with a moving average of 10. So I'm using the same here to generate the new data, which is going to be a moving average of 10. And then I'm changing the shape of that array and then assigning that list. It's a XTest is a list now. So I'm just assigning that list into an array and then reshaping the array so it will have the format that the model will understand. That is a 3-dimensional tensor format. Okay. So now the model has run. We'll see what it has gained. So what we are trying to do, what is happening here is we are trying to reduce the loss function as minimal as possible. So if you see here, the model's loss started from 0.2157 and it kept on reducing like 0.4 and then 0.3 and then 0.2 in some time. Sorry, 0.3 is the lowest. So if you, for 100 epochs, the model can maximum reduce to 0.03. Below that, it can't go. So since I trained it for 100 epochs, let's see how the model performs. So now what I'm doing is model.predict of x test. This is going to give me the uh, test data point, and then ypred equal to scale dot inverse transform. So it's predicting the values, but what we need is the original value, because we changed the values range between 0 comma 1, correct? Now I'm trying to get that change that 0 comma 1 into a original continuous value that can be something like 7800, 7899, or something like that. So that is what we are doing here. Okay. Now let's see. So if you take a look at it, we are saying blue line is the real price and orange line is the predicted price. If you look at it, we are actually able to closely get through the model. We are able to predict beforehand what is going to happen in the market given just the information, just a single column information, which is the close price, just a single column information. We are able to predict this. This is the beauty of lstms, or this is the beauty of rnn model, rnn architecture. You will be able to most closely resemble any time series data, any kind of time series data. It will perform as good as this. You just need to know how to represent the data, which is this three-dimensional tensor format, and then you just need to know how many epochs you have to run, how many layers you have to have. All these are iterative process. Till now, in the research and development area, there is no substitute for this iterative. All everyone is doing the same thing. They will try with one configuration. If that doesn't work, they will change it to another configuration. You have to iterate through the configuration in order to find the optimal models parameter that your data requires. Okay, there is no substitute for that, there is no easy alternative for that. The only way to do it is through this. Okay, we have seen predicting the stock volume, that is stock price, just with the close price. You can have multiple inputs, just like what we did. You can add all these three, high, low, close, all these four into a single emerged input, and then try to predict the price or try to predict the volume. You can do any such activity on this data given you have the data. So feel free to do so. Experiment around it, slice it, dice it, do whatever you can on the data. So it's 3-4. We'll take a short break. We'll reconvene at 3:15. Still, we have two more concepts to deal with. One is uh, one is the comparison between LSTM and GRU, and the another one is the LSTM for retail price data. We'll see those after the break. Okay, hi guys. I'm back. Let's wait for one more minute uh, for people to join if they have left. Okay, I think we can start. Again, what we tried to do was use the RNN or LSTM or GRU, whatever kind of recurrent neural network model, to predict time series. That is, we try to apply the particular network for a domain of problem that it's more suitable for. Okay, that is the time series prediction. Now let's see some other approaches where we'll be able to apply the same format, okay, in a continuous format, continuous type of data. Okay, so again, pandas is data frame, numpy is numerical calculation, matplotlib is plotting packages. So this retail price Canadian market.csv will be available in the GitHub for you to play around. Also, I'll sort of try to open that now just to show why I have done something like that. Okay, so if you take a look at it here, what I what I have done is I've said skip rows equal to 6, skip footer equal to 9, and engine equal to Python. Why I did that? Because the top 6 rows have unnecessary information in this particular CSV. The column details starts from this position actually. So I don't want these unnecessary details. So I can get rid of it directly in the directly while reading the file itself. So I don't have to wait, like I have to read the file first and check the format next, and then see if I don't need any data next, and then try to get rid of the data, doing some manipulation on the data, something like that. I don't need to wait for all those. I can open the file in my local machine and then see how the file is, uh, what are all the uh, what are all the rows as well as columns that are needed from the file for me, and then I can choose that particular rows and columns using the index. So I can say I don't need the top 6 index or the top 6 rows, and then I can say I don't need the bottom 6 because the bottom 6 used to be like empty values. Since it's a text, I'm opening it as a text file. If you open it in Excel or something, or if you open it in any spreadsheet reader, you will get to see that bottom 9 values will have empty values. It doesn't have any value, but someone have pressed space or something like that in it, so I don't want it, so I'm removing it here itself. These kind of special operations are also performed while using also available to perform in pandas. Just keep it in mind whenever you're stuck somewhere saying that it has more number of files, I don't need that or something. Just keep it in mind that there is an option to do that. It is in pandas itself. You don't have to worry about those. Let's see how the data is. Okay, you guys are hearing some sound, right? Just give me 1 second. I'll try to figure this out. Okay, I'm sorry about that. I hope it won't happen again. So we'll start. So as usual, I'm reading the CSV data into this file. I am reading the CSV data into this file, and then I'm just taking a look at the file, how it is, and what are all the data format it has. So it has an adjustments which is happening across month wise, and it has unadjusted price, and it has seasonally adjusted price. Okay, so what I'm trying to do is I'm trying to at least find a day. It just has this month, this year. So here we can use our lateral thinking a little bit and logical thinking a little bit. If we think laterally, we can say that, okay, I'm fine with January 1991, I don't need anything else. But if you go into the data and make an assumption and test that hypothesis, you'll be rewarded very well. Because if you take this as a plain data and then do some trying to fit a model on it, or try to train a model on it, you will never be able to get anything out of it. But if you try to do something like, let's say January 1991 is there, whenever some kind of adjustment is made in the retail price, it will be made monthly. So when that will be made, it will be made month end. So what I can do is I'll try to associate the month end for each and every month in this adjustments. So I'm just forming a new feature, creating a new feature from the feature that I have been given with. This is called feature engineering in our perspective. Okay. So what I'm trying to do is there is an option in pandas, or a method in pandas called month end, which will actually associate. Uh, so you'll never know, right? What is the date where the month end came in. So mostly it is going to be 31 and 30. Sometimes it's going to be 28, but in leap years it's going to be 29 for February, correct? So to get around with that, they have this wonderful function called month end. All I have to do is say that uh, these are all my timelines. Just add month end to it. So what I'm saying is this is my timeline. Add month end to it. So that is what essentially I'm saying. So if I say that this is what is happening, 1901, I mean 9101 is already there. 199101 is already there. I'm just adding 31 to it. Okay. So from here, this is the same step I did it before, just to show you how the data will look like. It's a series object. So what I'm trying to do is I'm trying to convert it into a data frame object, which is a column, and then set that column as an index. Since it's a time series, I'm setting that column as an index. So I'm just setting that column as an index. Instead of 0, 1, 2, it will have this value as its index. Now what I'm trying to do is I'm trying to plot the data. So if you take a look at this, the data is constantly increasing across time, constantly moving upwards. There is an upward stream and there is a downward stream, but the data is constantly moving upwards, and there is one small hitch here. There is one small hitch here which makes it go downward. Other than that, the data as a whole, data as a whole has only upward strike. Okay, that represents the Canadian market very well, which says the Canadian retail market has never seen a downfall over the years, which is from 1994 to 2014. But again, in a data science perspective, if you take a look at it, why there is a downfall? If for a market from 1994 to 2009, I mean 2009, let's say 2000, this is four, right? 5, 6, 7, 8, and 9. So till here, the market has seen no downfall, but suddenly it's seeing one downfall. Can anyone guess what it is? If you remember correctly, 2008 is the period where America has been hit with a recession, correct? The stock market collapsed, everything happened. At that time, the Canadian market also had an little bit downward stream, but the downward stream is so little that you have to zoom in and see it. So the Canadian market, the retail market is very strong nowadays. It's been strong for years actually. So these kind of intuitions, uh, uh, these kind of knack to understand why it is happening, or the keen to look into the smaller details in the data is very important when you are coming into AI, ML, DL, or data science, any domain for that matter. You have to have that ideology that you should take a look into the data and you should derive outcomes out of the data. Okay, if the outcomes, the the outcomes are the result of your expectancies. Okay, what do you expect the data to have is very well defined based on your outcome. Let's see what's going to happen. So as I said, time series data, we need to split it into two halves. So training and testing. What I'm essentially doing is taking 30% of the data into training and 70% into training and 30% into testing. I took a date which is in between the 70 and 30, and then I'm just trying to split the data into train and test. If you take a look at it, this is the train data and this is the test data. I just labeled it differently and then showed it to you, so that I didn't show it in the previous one because I didn't want to visualize there. I want to concentrate on the technical part more. This data set I took just to have a visual perspective of what's happening, and just to have a ideal look of what is going around on these things. Okay, again we are using the min max scaler. It is not necessary you should use a min max scaler. You can use different kind of scaling methods. There are so many scalers that are available. You can go and search online. Since it's not the scope of this session, I'm not able to cover it, but there are more than one kind of scaling methodologies which you need to try and which you need to get your hands on. So what we are trying to do is convert the values, unadjusted values, that is the values into unadjusted values into a range from 0 and 1. Okay, so from here, what we will do is we'll try to get a train data, test data, and then we'll also have a train X test and Y test. So essentially what happens is, you will, while training a model, you can say that this is my training data, this is my training, the training data has two parts. One is the input variables, another one is the target variable, and then this is my test data. While training a model, test it on this particular data and see whether it's performing well or not. You can say something like that. We'll see how to do it. So previously we saw TensorFlow, right? Now we are looking at Keras. Keras is another library which is like a wrapper. What do I mean by wrapper is, it is written on TensorFlow but provides low level API interaction. You don't need to do so. For example, I'll show you a perfect example here. So this is the code where we use TensorFlow, correct? So here, even TensorFlow has integrated Keras. If you take a look at it, it says tf.keras.models.sequential, correct? But when it comes to Keras alone, you can say something like from keras.models import sequential. Okay, so that is what you need. So Keras is like an wrapper API which provides you with low level interface. You don't have to worry about the codes and stuff. You just have to import the proper layers to get the model on board. Okay, so again we are using a dense model here, we are using a sequential model. This is a the backend k is nothing but whether we need some, whether we need to clear a session or whether we need to start a new session, something like that. Here what session is, whenever you are training a model, that model training happens as a particular event in your system, in your computer. Okay, that event can be catched in your system for a long time, but you don't want that in your system. You can clear that session and you can start a new session, something like that. Cached meaning it will be stored in a in a location where you can't access, as well as where you don't have control over it. So that is why we need to clear this session. Also, here we are going to find a new thing called early stopping. I'll explain it when it comes there. We'll see how this Keras works. Okay, what I'm doing is I'm adding a sequential model, I'm adding a dense layer to it, I'm adding a hidden layer to it, and then I'm adding a dense layer, which is my output layer. So this is a very simple model. It's an input layer and then an output layer. That's it. It has a compile mean squared error, which is MSE, and then it uses the optimizer, Adam optimizer. So let's see the model summary. The model has just one dense layer, which is going to be my input layer, and then one dense layer, which is going to be my output layer, and then early stopping. What I meant by early stopping is, so here when we started training our model, we said 100 epochs. So the model ran for 100 epochs, correct? Yes. But what should happen in a model training is the loss should go down. If you remember, today morning I mentioned something about gradient descent, correct? How the loss should go down in a curve and then we should reach the optimal point. Yes. If you take a look at this loss function, okay, it's been going down. See, take a look at here, exactly at this position, between these position of the loss function. It's 0.047 here and 0.051. It's increasing actually. So this would be my minimal point, because it's repeating 472 two times and then it starts increasing, and then at some point it's decreasing, and then again it starts increasing. So now the model has been overfitting. We don't want the model to overfit. We want the model to be at its best, correct? So what we are trying to do is, I can say how many epochs I want, but please stop the models training using the loss as a metric. Where to stop and when to stop. Where to stop? When to stop? You need patience equal to 1. That is, whenever the loss is increasing just 1 point, stop the model training. I'm happy with that place itself. You can say 5. If you say 5, it will check for 5 iterations, 5 epochs. Okay, 5 epochs to see whether the model's loss function is reducing or not. If it is not reducing after 5 epochs, it will stop the model's training. We'll take a look. Let's see. I said the model epochs is 200, and I call this callbacks, which is going to be my early stop, which is the configuration that I use here. This is just a configuration. I'm importing that configuration here. Let's see what happens. So it's been reducing, correct? It's been reducing. After 0.99, it's not going to increase anywhere. So it stopped the epoch at 24. But when I said 200 epochs, the model should run for 200 epochs. Because here, that's what happened. If I said 100 epochs, the model will run for 100 epochs. There is no other alternative for it. It should run. But here we are associating a rule to it, saying that I don't want you to run for 100 epochs, 200 epochs. I'm just saying you to run 200 epochs. That's the number that first came into my mind. You just stop yourself wherever you deem fit. The deem fit position is what we called as a patient. Okay, and now we'll see how it performs. So we are just predicting the model, and then we are going to say predict y test comma y pred. As I said in the previous example, the predicted line should overlap or above the real price, correct? Here the orange is the predicted line, blue is the Below is the original adjusted price. So it should be above, not below. So that's the intuition, right? So what we will do is, if you take a look at here, this is just a simple RNN model. Previously, we tried LSTM in the Maruti stock price prediction. I also wanted to introduce you to a simple RNN model. This is a simple RNN model. It doesn't have LSTM or GRU. It just have a sequential model. So it's a simple RNN, SRN network. Now what we are trying to do is trying to do the same thing with the LSTM network. So if you remember correctly, in the last Maruti stock price prediction example, I said that the model expects the value to be in a three-dimensional tensor, correct? Batch size, time steps, input dimension. Let's see how this goes. So here, instead of the input layer is an LSTM cell of 6 units, and then the input shape is this, and then there is a dense layer for output. Again, it's just an input layer and an output layer, and then the mean squared error. We'll see how this works. Also, I'm using the yearly stopback here. So the yearly stopback will be used to stop the model at whatever time the model deems fit. So if you take a look at it here, previously in the simple RNN model, it goes till 24. Yes. But here the models reached its optimality at 10 epoch itself. Look at the performance or the learning rate difference between a simple RNN versus the LSTM network. There in SRN, simple RNN network, it needed 24 epochs. Here it just need 10 epochs. Okay, again we'll try to predict what is happening here. So if you take a look at it, the overlap has been reduced, correct? The overlap has been reduced. That is, wherever it came below, it's slightly able to cope up with what we want. Okay, but it's not enough. It's not enough. So if you want to, I'm sorry, once again, I'll zoom out. So play around with this data. I have also added the code here. You will see the model's output like this, which is completely on the real price. The predicted price should be completely on the real price. Play around with this data, take your own time, try to see what's happening, why it is happening like that. But all these things is what I explained in the Maruti stock price prediction as well. That is what I'm essentially doing here. So if you take a look at it, you will get to know. Also, there is an alternate approach that you can take, right? Because I added two alternate approaches that we can try for the same thing. Just to be, I'm sorry. Yeah, I'm sorry. So alternate approaches is I will give you an idea about what can be done. So based on the learning that we had in this session, you can try to. Yeah. Any questions? I hear some noise. Okay. So alternate approach is nothing but I'll give you an approach to take, and I will tell you the steps to take. So these are the steps that I want you to take on this alternate approach. Please feel free to try. In case, like, if you are too swamped up with your work and stuff, no issues. What I've said so far in the simple RNN as well as the LSTM network is completely enough in implementing any kind of LSTM networks or simple RNN networks. We'll also see about the GRU network next, which is where we'll try to compare the performance of both the LSTM as well as the GRU. Okay. So this now what we are trying to do is sentiment analysis with IBM dataset. So we tried time series problem. We tried a numerical problem. Now we are going to try text-based problem. Okay, let's see. This movie data.csv will be available for you on the GitHub. In case any of you doesn't see the GitHub link on the current meeting chat box, please let me know. I'll paste it again. So this is what I'm essentially doing is I'm trying getting the loading the data and then seeing the data how it is, what are all the columns there, and then I'm splitting the data into train and test. This is what we have been covered so far. So there should be no doubt in this. So let's see the shape of the training data. So it has 50,000 data points. Overall, it has 50,000 data points. Now, what we will do is we'll try to get the data in a format that the GRU or LSTM cell can understand. Okay, what we are trying to do is we are trying to tokenize the data. What I mean by token is I comma. So if there is a line like I went and saw this movie last night, so the tokens will be I comma went comma and comma saw comma this comma movie comma last night. So that is the token. You are just splitting word by word. Each sentence, each paragraph, each document will be splitted word by word when you pass that into this tokenizer. Okay. And then what I'm trying to say is, what I'm trying to do is, I'm trying to associate an index to each and every word in the token. Each and every word will be a number, because machines mostly or widely understand numbers, correct? We can't just directly go and say this is a word, try to learn this word. No, it's not possible. Still, it's not possible for a machine to understand words. Everything will be represented in a numerical format, in a dimensional, vector dimensional, or a matrix dimensional space that a machine can understand. So, so what we are trying to do is we are trying to assign each and every sequence, each and every tokens in each and every tokens in the document with an index, that is with a number that it can uniquely represent. Okay, that is what we are doing here. This tokenizer is essentially splits all the words in a document or in a sentence into a token, and then this text to sequence will convert each and every text into a number. Okay, now what we are trying to do is we'll see the vocab size. Vocab size is nothing but, okay, it's running actually. So also this pad sequences. This pad sequences is nothing but you will have varying sentence length, correct? It's not necessary that each and every review should be equal to this particular number of characters. No, they say the maximum characters is this, the minimum characters is this, but they do not limit the actual number of characters. So you will have varying input size. Now, how to deal with this varying input size is you can add or remove the tokens based on your input size. Let's say the maximum input size that you have is 1000. Okay, there is a review with 1000 words, and there will be a review with just 10 words. What we are going to do is add a padding. Padding is nothing but we'll add this variable called unknown, just a string unw. We'll add that string to each and every document in the CHV in the columns. Will add this unknown variable to the maximum length, just to make sure that every sentence is having the same dimension. Okay, so essentially this means that we have a vocab size of 12,000. I think it's 1,25,602. So we have 1,25,602 words in this movie data set. Okay, now what we are trying to do is we are trying to build a GRU model. Now note this particular configuration. We are embedding. We are building a model with 100 dimensions as a word embedding. So embedding dimension is this, and we are building a single layer with 32 GRU cells, and then the dropout is 0.2, and then the recurrent dropout is 0.2. Okay, and then we are building a final activation layer, that is the output layer, which has a sigmoid model, and then the binary cross entropy is my loss, because since it's a binary classification problem, I use binary cross entropy as my loss, and the metrics that I want to overcome is the accuracy. I need to increase the accuracy of the model. Okay, this percentage division. This command in Jupyter Notebook is used to tell us the time taken for this particular cell to execute. The CPU time, the wall time, the system time, all these time taken for this particular cell to execute. Okay, let's see how it does. So it says 666 microseconds. Okay. So the model has been created. It has a one embedding layer, which is converting text into embeddings, and then one GRU layer, and then one dense layer. Done. It's done. Okay. Now we'll train the model. Let's see what's. So also remember this. Already I trained this model. It took 1 minute 6 seconds. Okay. So this is a GRU model. Okay. Again, if we want to evaluate, I have the X test and Y test, which I already separated. So all I have to do is call this model dot evaluate of X test and Y test to just to check the accuracy of the model. So that is running. Let it run. We'll also come into this. We'll see this LSTM based implementation. So if you take a look at here, here we are trying to build an LSTM model, the same sequential model, which has the embedding dimension of same format, which is as a GRU, and then it has a LSTM cell of 32. It has a LSTM layer of 32 units, and then it has a dropout of 0.2, recurrent dropout of 0.2, and then the activation layer is sigmoid. The loss is binary cross entropy. Optimizer is Adam optimizer. Metrics is accuracy. All these things are same. Okay. The model has ran. Let's see. Again, it took 1 minute 12 seconds, which is 6 seconds higher than what it took earlier. So now we'll do the same thing for the LSTM model. So I'm compiling the model, and then I will train the model. So the compiling the model took 10.1 seconds. Okay, now let's train the model. So let it run. The whole idea, while it's running, let's see let's see the model configuration parameters. See, for LSTM we have embeddings, which is of dimension 500, 100, and then LSTM cell, which is 32 units, and then a dense layer of one dimension. Okay, let's see the GRU one. It's an embedding layer of 100. Again, it has a GRU of 32. It has a dense layer of 1. So essentially, these two are same parameters based model. The only difference is this. There is an LSTM cell here. Instead, there is a GRU cell there. Okay, for that, let's see the time taken. The time taken is 1 minute 12 seconds for the GRU model. Let's see the time taken for this LSTM model, and then we'll come to the conclusion whether whatever we said theoretically in the morning is holding its proof while we are trying it out. Okay, while the model is running, I think it's 3:50, so let's have this FAQ session. You people have any doubt, feel free to ask. Yeah, I'll try to answer as much as possible, I'll try to convey my knowledge as far as I know to you. So in general, if you take a look at it, you will notice that it's been running for more than 1 minute 6 seconds, because as we said in the morning in the theory session, LSTMs are supposed to run slower than GRU and supposed to be computationally extensive. than GRU. The memory requirements as well as the time requirements, time running time requirements are higher for LSTMs. This will prove our case. This will actually prove our case. That is why I wanted to show this demo. Uh, but unfortunately, it's running more than the time I thought, because initially the LSTM model ran for 3 minutes. Uh, Now it's taking more than that time, I guess. I'm not sure. Yeah. If you have any questions, just let me know. I'll be happy to answer those. Also, someone is asking feedback link. Someone has asked feedback link. Uh, I'm not sure. I think Shanti ma'am is supposed to produce that.
So we will share this feedback link at the end of this session. No problem. You continue.
Okay. Okay. Cool. So yeah, it's taking more than 2 minutes, I guess. It's been 2 minutes, right? I think I started it on 3:49. It's been more than 2 minutes, but still the model is training. This actually proves our point that that LSTM is time consuming, LSTM is memory required uh, than the GRU model. But people are not, see, it has taken 3 minutes 53 seconds. At last it ran. Okay, I thought some error and it won't run. So it took 3 minutes and 53 seconds. So the CPU time is like 6 minutes 52 seconds. Let's get into the GRU part. Let's see the CPU time there. It's 1 minute 56 seconds. It's like uh, GRU is six-fold better than LSTM. Yeah, you guys accept the fact that GRU is better, right? It's always good to see these kind of contradictions, these kind of debates in proof. I'm a visual person, as I said. I'm a visual person, so I try to see what's there. If someone said uh, it's performing really well, it's performing this, it's performing that, we are expecting this, something like that, I'll always go for visual proof. I'll have to see it. I have to feel it tangibly. If it isn't there, then I don't accept it. So please, like, follow this follow this in your heart, just to, whenever you hear something, try to attain a conclusion on those things by looking at tangible results, not like intangible ones where people say something and we just accept it. So this actually holds proof that LSTM is lower than GRU. LSTM is computationally intensive because it took 6 minutes. The CPU time, it took 6 minutes. The running time, it took 3 minutes 53 seconds. Computationally, it took 6 minutes, and running time, it took 3 minutes. But when it goes to GRU, computationally, it took just 1 minute 56 seconds, and the running time, it took just 1 minute 12 seconds. So yeah, uh, I rest my case, and that is the overall idea behind LSTM GRU for time series prediction, as well as sentiment analysis, as well as for time series data or text data or normal numerical data for that matter. Any questions? We have 5 minutes left, I think. To morning session, I ended very lately, so people asked question and the session extended, so I don't want to continue. I don't want to do that again. So I'm ending my session beforehand. Any questions, feel free to ask. Sorry, someone asked any. Yeah, did they?
Any questions you can ask now.
Yeah, I
Imayabadi
think.
is waiting for your question.
I think someone asked something about configuration, but I didn't hear it clearly. Sorry, can you repeat that again?
Okay, Maya Bharati, I hope there is no doubt from the participants, no queries from the participants. We will conclude today's session. Thank you for all for your patient listening as well as for giving an excellent presentation to the participants. Thank you, Maya Bharati.
Thank you, ma'am. Thank you for this wonderful opportunity, and thank you, people, for listening so valiantly. You guys have been a wonderful crowd. Thank you so much. Bye bye.
So feedback link is shared in the chat window. All are requested to fill the feedback. Again, we will meet by tomorrow 10 a.m. Natural language processing. Thank you, one and all.